Key concept 8, target B. Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors. Alright, so vocabulary for this target is scatter plot. Definition: a graph of plotted points that shows the relationship between 2 points. So below to the right, I provided you guys an example of scatter plot. Notice it's basically a graph, right? And it has a line, but you'll notice that the points are not necessarily all on the line. Some of them might be, but a majority of them are located either above or below. Okay, so it's impossible to draw one straight line that'll intersect all those points. So the line that we can create is called the line of best fit, also known as a trend line. A trend line because it sort of shows you the pattern or what's going on at the moment. So the definition was a line that best represents the data on a scatter plot, may pass some, none, or all the points on the graph. We could calculate the line of best fit by hand, but it's more work than necessary. So we're actually going to be using our TI Inspire software on their laptops to calculate the line of best fit. Okay, and keep in mind, since we're looking at lines, we're going to be looking at slope-intercept form, y equals mx plus b. So we'll be talking about slope and y-intercept at some point in this target. Example 1. The following graph shows the value of a car as the years pass by. Okay. Now, before we start answering the questions, keep in mind the next few slides will still be example 1. I just wanted to make sure I had enough space to work with. And before we answer the questions, let's take a look at the graph, make sure that we understand what's going on in the graph. So first things first, the title, used car value. And then on the x-axis, we're looking at time purchased in years. Notice that it's going up by 1, the scale, right? And then on the y-axis, we have car value in thousands of dollars. So when you see 1, 2, 3, 4, know that means thousands of dollars, right? Now, question A says, what is the rate of change? And then describe what the rate of change means in the context of the problem. So it's 2 parts. First, calculate the rate of change and then describe it. Now, rate of change just means slope, okay? And the reason it's called rate of change is because slope we already know is equal to letter m. And the way we calculate is change in y over change in x. That fraction right there is what we call rate. It compares two things, usually in the form of a fraction. In this case, what's being compared is how does y change over how does x change. So we need to calculate slope. So we need the slope of this line, which means we need at least, or not at least, but exactly 2 points that are on the line and that they hit the corner of the boxes. So going from left to right, the first good point I see is 0, 11. Keep going down, keep going down. The next good point to use would be 4, 8. Moving it along. Now we have 8, 5. And then the last good point would be 12, 2. Okay. Out of all the points on this scatter plot, on this graph, those are the only 4 good ones we could use because they're actually on the line and they're on the corner of the boxes so that we know exactly what they are. Okay. Now, there's a couple ways we can calculate slope. For this example, I'm going to calculate it by counting boxes, and then maybe for a different example, we'll go back to slope formula. Keep in mind that you could use any method you want here as long as you do it correctly. All right, so slope, again, we know is the letter m. The way we calculate it is change in y over change in x. Out of those 4 points, I can use any 2 I want. I'm going to go ahead and use the first 2 from left to right, just to get into a pattern of stuff. I'm going to start with 0, 11, and then I want to work my way to 4, 8. So changing y tells me that I have to either go up or down. In this case, I need to decrease 1, 2, 3. And because I'm going down, it's going to be negative. But also keep in mind the label of the y-axis was car value in thousands of dollars. So when I travel up and down, I'm counting in thousands of dollars. So that's going to be negative $3,000. And I need to travel to the right for the change in x. 1, 2, 3, 4. Keep in mind again, that's time since purchase in years, and because we went to the right, it's going to be positive 4 years. Okay. Now, the first part of this question was what is the rate? What is the slope? So we basically calculated here. However, we still need to simplify that fraction. So on your TI Inspire calculator, you can do negative 3,000 divided by 4, decimal point, press enter because we want an actual simplified answer. That should give you the final answer. And actually, I'm just going to take it to the next line, where m equals negative 750. Okay, that is our slope. The second part of the question says, describe what the slope means. So let's put this over 1 because we need slope as a fraction in order to figure out what it represents. That top number, negative 750, comes from change in y. So if you go back and you look at your y-axis, we're talking about car value, so that's negative 750. It's no longer thousands of dollars because we already accounted for that when we put negative 3,000. So that really is just negative $750. The denominator, the number on the bottom, comes from your change in x, which is time purchased in years, so this is going to be 1 year. Okay. And if you look back at the title of the whole thing, used car value. Okay. So what this is telling me is that the value of my used car is decreasing $750 every year. The value of the used car decreases $750 each year. Notice I didn't put negative 750 because the word decreases already lets me know that we're losing money, and it happens each year. Okay, so we successfully answered both questions. We calculated the slope to be negative 750, and looking at the graph and considering change in y and change in x, the slope, we're able to figure out what it represents. This is example 1 continued. Now we're looking at part B. Part B says what is the y-intercept, and describe what the y-intercept represents. So 2 parts like part A, a little bit easier because the y-intercept is easier to calculate. The y-intercept is just where does my line cross the y-axis. So here is the y-axis, right? I'll even trace it so we can look at it. I want to know where does my line cross it. So here's my line, right? And if you follow it, you can tell that it crosses it right here at 11. But keep in mind, that's a y value, so we're looking at thousands of dollars. So y-intercept, which we know is represented by the letter B, is going to go ahead, it's going to be 11,000. Okay. And the second part was to describe what that represents. So we know that's the car value, $11,000. We just need to figure out at what year, so we follow it all the way down. It corresponds with the year 0, which means no time has passed since you bought it, so that means when you first purchased it. The value of the used car when first purchased was $11,000. So also put, instead of first purchase, also put the initial value. So the y-intercept, where does my line cross the y-axis at 11,000? And then what it represents, the value of the used car when first purchased, also known as your initial value. Example 1 continue. We're looking at part C now. A trend line has been drawn to the scatter plot on the previous page. Write the equation for this trend line. So a trend line, remember, is a line of best fit. So what we have here is a scatter plot. There's a bunch of points scattered, but there's still a relationship. Okay. We can still tell that as time is increasing, the value of the car is decreasing. However, we can't draw one straight line that will touch all the points. So what we do is we calculate the line of best fit, and usually this is done by calculator. Now they want the equation for this line. Okay, and when they say this line, they're talking about this one. Now, because we're looking at a straight line, we're thinking slope-intercept form. Okay, which is the equation of a line, slope-intercept form, which is y equals mx plus b. Now, in order to create an equation for y equals mx plus b, you need slope m and y-intercept b. In part A, we calculated the slope, so we can go ahead and plug that in. So y equals, we found that the slope was negative 750 in part A. Keep your x. And then in part B, we calculated the y-intercept, which we found out to be 11,000. So that right there will be my equation. Okay. Now part D, use the equation to predict the value of the car 14 years after it is purchased. So we're going to go ahead and use this equation. Now keep in mind, y represented car value, right, from the y-axis. And x represented time since purchased. It says use the equation to predict the value of the car 14 years after its purchase. So we don't know the value of the car. So we don't know y, but we do know x, how many years. So we're gonna let x equal 14, and we're gonna go ahead and plug it into the equation that we got for part C. Okay? So the equation was y equals negative 750. But for x, I'm gonna go ahead and plug in, I'm gonna substitute 14 years, close it up, plus 11,000. So first thing we'll do is multiplication. Negative 750 times 14 is gonna give us negative 10,500. And then we're gonna add 11,000 to that. So we'll get a final answer of 500. And then that 500 represents the value of the car 14 years later. So we'll just go ahead and put down $500 as a final answer for that question. Example 2. The scatter plot below shows the income earned in dollars from mowing yards. Okay. Keep in mind, it'll probably be the same example 2 for the next couple slides. Looking at the scatter plot before I try to answer the questions, title, lawn service income. So income is money that's coming in that you're making. On the x-axis, we have the number of yards mowed. Now keep in mind, they're going from 10 to 20 to 30, so they're going up by tens. However, to go from 0 to 10, it's 2 boxes, so each box must be going up by 5s. Okay. And then on the y-axis, we have how much money we're making. Again, they're going up by 200, from 200 to 400, but between them there's 2 boxes, so each box is really going up by 100. Okay. Now you can tell by looking at the graph from left to right that it's increasing, so the more yards are mowed, the more income, the more money I'm gonna make. And it's in dollars, it's not thousands this time. So looking at question A says, a trend line has been drawn to the scatter plot. So a trend line, remember, is a line of best fit. It shows you the trend, the pattern that's currently happening. Use the points 10, 300, and 2600 to write the slope and intercept form of the equation for the trend line. So they give us 2 points, 10, 300. So 10, 300 would be right here. The next point is 2600. So 20 to the right, 600 up. They want us to calculate the slope intercept form. So slope intercept form is y equals mx plus b. So they basically want the equation of this line. Okay. So that means we're gonna have to calculate slope, and we're gonna have to figure out the y-intercept. Starting with slope, we could count boxes. This time around, though, I'm gonna use a slope formula just to show you that there's multiple ways to solve the same problem. So the points we're gonna be using are 10, 300, and then the next point is gonna be 20, 600. We're gonna use the slope formula. So m equals y2 minus y1 over x2 minus x1. Before we use the slope formula, though, we're going to plug in the values into the correct spots. 10, 300 was our first point, so I'm going to go with x1, y1. And then 2600, because it's the second point we see, we're going to label that x2, y2. Okay, so plugging things in where they should be. The top of the formula, the numerator starts with y2, which is 600, minus y1, which is 300. Over x2, which is 20, minus x1, which is 10. Okay, so on the numerator, 600 minus 300 is going to give you 300. Your denominator, 20 minus 10, is 10. And then 300 divided by 10 is just going to give us 30. Okay. So what we have there so far is the slope. The next thing we need is the y-intercept so that we can create an equation. So b is the y-intercept. Again, that is where does your line cross the y-axis. So you go down, and here's the y-axis. They intersect at the point 0. So your y-intercept is just 0. And the last thing we're going to do is we're going to actually write the equation like they wanted us to. So y equals mx plus b. For m, we're going to go ahead and plug in 30. Bring down the x. And because b is 0 in this case, we don't need to include it. So our final equation is just going to be y equals 30x. Example 2, continued. We're looking at part B now. Use the equation to predict the income earned for mowing 80 yards. In part A, we came up with the equation y equals 30x. Keep in mind the y-intercept was 0, so there was no need to put it, but we did calculate slope. Now we need to figure out the income earned for mowing 80 yards. So y represented our income, and x represented the number of yards. Okay. We do not know the income, that's what we want to predict, but we do know how many 80 yards. So we're going to go ahead and let x equal 80. And we're going to go ahead and plug that into the equation for x. We're going to substitute it. So y is equal to 30 times 80. Okay. And then there's not much to do there. You're just going to do 30 times 80, which is going to give you, let's see, 2,400. So what's the income earned for mowing 80 yards? $2,000, 2,400. Final answer. All right, now we're going to use the TI Inspire software on our laptops to do something called linear regression, which is basically we're going to come up with the equation of a line using the TI Inspire. So we're going to calculate the line of best fit. We're not going to do that by hand, even though we could calculate slope and y-intercept ourselves, because we want to make sure that it's incredibly accurate. So these are the directions. First, you need to identify the TI Inspire icon on your laptop. We're going to double click it. It should have it running. It will take a while to load, so give it some time. If a window pops up saying if you want to take some kind of survey or update it, say no. And then sometimes you won't see this right away. Okay, so let's say that you don't actually see the calculator right away. This icon right here, you need to click that one in order for the calculator to show up. If you do not click it, it's going to take you to maybe another one that looks like it's Windows or a file folder. You need to click this calculator icon for this calculator to show up. Okay, and then at that point, go ahead and click the home button, and it should take you to this screen right here. Okay, now feel free to come back and revisit this page if you need the directions on how to use the calculator. Basically, yeah, you're going to start home. You want to do a new document. If you've been using it previously, it's going to ask you if you want to save the unsaved document. Just click no. You're going to go to add list and spreadsheet, and so on and so on. All right. Each of these steps I'll go over in the next slide or so. This is more just a recap so that you guys can see what you need to do. Example 4. The data table shows the average price of the ticket to a basketball game from 1995 to 2003. Okay, and if you look at the table, we have a 2-column table. We already know the top row should be X, your independent, years since 1995. Notice it tells you how many years since 1995. So when they say 0, they're talking about 1995, right? When they say that it's been 1 year since 1995, they're talking about 1996, and so on. Okay. Y, average price. It goes from $11.50, and then it keeps moving on. All right. Now, TI Inspire. So what we're going to want to do, we're going to go to Home. If you're already there, we're going to click option number 1, which says New Document. It's going to ask you, do you want to save unsaved document? It will only ask you this if you've already been working on the calculator previously. But if it's your first time opening, this step might actually be skipped. But we're going to select no, because you want to start fresh. And then it should take you to this screen right here. We're going to go ahead and put option number 4, which is add list and spreadsheet. Okay. Now, once you click there, it's going to take you to a spreadsheet that looks like this, except yours should be entirely empty. Now, column A is going to correspond with X. You want to type strictly one word and only one word, no spaces. So even though the X value is labeled here as years since 1995, keep it to one word. Whatever word you think is most important, doesn't really make a difference. And again, no spaces. Column B will always be your Y. Okay, so you're going to give it a title. Type it using the keyboard that's located at the bottom of your calculator or on the one on your actual laptop. Now again, keeping it down to one word, even though the title is average price, to me price is more important, so I labeled it price. Then what you're going to want to do, you do not want to put anything here. Okay, so I'm going to cross it out. If there's anything there, your TI Inspire is not going to work. You're going to want to enter all your X values starting from 0 all the way to 8, starting with cell number 1 and then going straight down until you've entered them all in. Make sure you enter them all in carefully, because if even one of them is incorrect, it's not going to show up correctly. Okay, then you're going to want to take all your Y values, put them into this first cell, and then go straight down. Okay, again, you want to make sure that they're all there. Double check your table, make sure it's correctly, put it in the exact order that you see. Now the last thing I want you to do here is go ahead and click on this cell, which would be C1, and make sure that it remains blue. If you see your cursor still blinking, so for example, if you see a line like that that lets you know your cursor is still blinking, your calculator will not let you move on because it's assuming that you're not done inputting values. So make sure to click that box just once so that it shows up blue, and then we're ready to move on to the next step. Okay. The next step, you're going to go ahead and click this menu option. Once you click that menu option, this menu is going to be the first one that comes up. We're on key concept 8, which is statistics. So from here, I'm going to want you to choose option 4. Okay. Option 4 will then take you to this window right here. Out of those 4 options, we're going to go ahead and select stats calculation. So we're going to go ahead and select this one right here. Notice that if at any moment you make a mistake and you select the wrong one, you can just click this button right here on the calculator, the escape button, and it'll go back one menu, and then keep pressing it until it takes you all the way back. Okay. Now we're currently here. We just clicked stat calculations. All right. The next step will be this. Okay. You just happen to click stat calculations. What's then going to come up is this option right here. Okay. I told you guys before on a previous slide that the method is called linear regression. We basically want the equation of the line. So the one we're familiar with is mx plus b. So that's the one you're going to select. Okay. You do that, it's going to then lead you to this screen right here. Okay. Which is basically, it's going to ask you to identify what is your x and what is your y. I do not want you to type it in by yourself. For the x, if you click that little arrow, you're going to see a little menu drop down, and it's going to say years or price. If you go back to your table, we had said that years was x. So when you click this little arrow, you're going to go ahead and select years. You click this arrow next, you're going to go ahead and select price, because price is what we said was y. Once those two things are where they should be, those are the only two things you're going to press, you're then going to move to this button that says OK, and that'll take you to the next menu. Now, when you click that next option, OK, it should take you to a screen that looks like this. Okay. If you cannot see this, you might need to press one of these two arrow buttons from left to right, because maybe your screen is not exactly where it should be. You might also need to press this up button or this down button to navigate until you see this. And what's really important here is we want to be able to see M and B, because M is our slope, B is our y-intercept. All right, so moving on to question 8. Question 8 says use the data table to write the equation for the line of best fit. Notice we were never given a scatter plot here. What they did give us was a table, okay, with the X value year since 1995 and the Y row for average price. So we want to come up with the line of best fit. It's not like the examples we did before where they gave us a scatter plot and the line. In this case, we were given the table and we need to come up with the line of best fit. So when they say equation, they're talking about y equals mx plus b. Okay? So first thing I want is my slope. I want you to click on this cell right here next to M. Okay, when you do that, down here, the actual lengthy number is going to be displayed. So that's actually 1.36 repeating. I want you to round to 2 decimal places. So what we're going to do, like we practice in class, you're going to give me, because I want to round to 2 decimal places, you're going to give me 3 after the decimal. So in this case, it's 1.366. And because I want you to round to 2 decimal places, we're going to start by looking at the number that's in the second decimal place. We're going to go to the one on the right. We already said before, if it's 0 to 5, that 6 that I boxed out will stay the same. If the number to the right is between 5 and 9, then that 6 is going to be increased by 1. In this case, the number is 6. That means I'm going to add 1 to that 6. So my slope will then become approximately 1.37. Okay? Now, we're gonna do the same thing, but we wanna do it now for your y-intercept. So for B, you click there, the cell should become blue, and down here will be the actual number, which is 12.58 repeating. So again, B equals, I want you to round to 2 decimal places, so you're gonna give me 3. We have 12.588. Again, starting with the second decimal place, because that's where I want you to round to. Look to the right, because it's 8, we're gonna add a 1 to the 8 that's boxed up. So this is gonna become approximately 12.59. Okay, we now have slope and y-intercept. We can go ahead and write the equation as y equals mx plus b. So we have y equals m, which was 1.37. Bring down the x. Our y-intercept plus 12.59. So our final answer for part A is y equals 1.37x plus 12.59. Example 4, continued. We're looking at part B now. Part B says, use your equation to predict the price of a ticket in 2015. So first I'm going to start with the equation that we got in part A. So that equation was y equals 1.37x plus 12.59. Okay. Now, it says use your equation to predict the price of a ticket in 2015. Remember, y represents the price, and we get that from the table. Okay. X represents the year since 1995. That's a huge distinction right there, and we get it from right here. Okay. Now, the reason that's a big deal is because we want to predict the price. So we don't know the price, which means we don't know y, but we do know what year we're talking about. So that's this right here. However, this tells us how many years since 1995. So I do not want you to plug in the year 2015 into your equation. Rather, in the year 2015, how many years has it been since 1995? So if we do 2015 minus 1995, that should tell you that it's been 20 years since 1995. So what we're going to plug in is the x value 20 into the equation. So we have y equals 1.37, there's x, which we're going to plug in. We're going to substitute 20, and then plus 12.59. Okay. We can actually put all this into our calculator at one point. Notice I created, or I pasted these two slides just to show you that that's where we got our slope and from our y-intercept from the previous screen. Not a big deal. But if you go back home and then you choose calculator, you're just gonna type in 1.37 parentheses 20, close it up, plus 12.59, and that should give you the answer of 39.99. Okay. So use your equation to predict the price of a ticket in 2015. The price of a ticket in 2015 is going to be $39.99. Final answer. Example 5. The data table shows the amount of calories burned over a span of 9 weeks. So the process is very similar to the one we just did. Where X is going to represent weeks, and then calories will be Y. So again, we're starting by pressing home, and then from there you're going to select new document. Since we were just currently working on one, it will ask us if we want to save the unsaved document, which you'll say no. And then from there, we're going to go ahead and add list and spreadsheet. So that should lead you to a spreadsheet that's completely empty, a brand new one. Example 5 continued. So from the previous slide, again, you end up with a blank spreadsheet, but we're going to go ahead and plug in some values. In column A, remember, it's going to be X, so weeks, one word. For Y, we're putting in all our Y values. We're giving it a title too. Calories burned, to me, calories seem like a more important word. Again, this second row with the equal sign, Never put anything in there. If you ever have anything in there, you'll notice that your spreadsheet's not going to work. Okay. Now, we're going to take all the x values, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to go ahead and take those and plug them into column A. Then you're going to take all your y values starting from 567 to 5,117. So a point that I do want to make here, and you can notice once you take a look at my values there, if the number is large enough where you need a comma, do not put a comma. Okay, so for example, 1,245, this number right here, do not put the comma when you put it into the spreadsheet, because if you do 1,245, that's going to read it as you have two numbers. The first number being 1, the second number being 245. So just put that in as 1,245, no commas whatsoever. Then from there, remember, click on C1, making sure that the box is blue and that the cursor is not blinking. So if you see a cursor like that and it's just blinking, click it again so that you get the blue box. Then once you do all of that, we're gonna go click menu. When you first click menu, this table or this menu will pop up. Then you're gonna go ahead and select statistics. When you click statistics, this menu is gonna pop up. And from there, you're gonna go ahead and click set calculations. Example 5 continued. So we just click set calculation. So the next thing you're going to want to click, but when you click that, this menu right here is going to pop open. From there, the option we're going to want is option 3, linear regression, mx plus b. That's the one we're familiar with. You click that and it's going to lead you to a new menu. The new menu will look like this. Remember, on this, we need to adjust the x and the y. Again, you are not typing in what x and y is. They should automatically come up. So when you click this arrow right here for x, you're going to notice that it's going to drop. There's going to be a drop-down menu. You're going to go ahead and select weeks because that's what we said x was. Then you're going to go ahead and click this arrow right here, and a couple options will show up. You're going to click calories because that's what we said y was. Once that's all done, you're going to go ahead and click the OK button. Example 5 continue. Once we click the OK button from before, you're going to get basically this window right here, which will calculate your M and B. Again, keep in mind, if you don't see it right away, you may need to click the left or right arrow until you do see it. And if you still don't see it, the up and down arrow might put you to eventually right here where you see M and B. Keeping in mind that what we want is M and B. Now, question A says, use a data table to write the equation for the line of best fit. So we want y equals mx plus b for our equation. So starting with slope, again, I'm going to want you to round to 2 decimal places. So click on the box that says m, or the number, right? And then this number down here will show up. Because I want you to round to 2 decimal places, you're going to need to give me 3 decimal places. So 516.033. And because I want you to round to 2 decimal places, and the second decimal place location is this 3, you look to the right, because the number to the right is between 0 and 4. The 3 will stay the same, so this will be approximately 516.03. Remember, approximately means really close, but because we rounded, it's not an exact answer anymore. And now click the box next to B, and we're looking at this number right here, our y-intercept. So again, because I want you to round to 2 decimal places, you need to give me 3 after the decimal. So that's negative 194.277. Because we're rounding to 2 decimal places, we're going to start with this 7 right here. Look to the right, because that number to the right is between 5 and 9. We're going to take that 7 from before, and we're going to add 1 to it, so this is going to become approximately negative 194.28. Now we have the correct slope and y-intercept to plug into our equation. So we have y equals m, which we figured out was 516.03. Bring down the x. Our y-intercept, which was negative, so rather than put plus minus, we're just going to put minus 194.28. Final equation and final answer for part A. Example 5 continue. Now we're looking at part B. So I pasted the screenshots from before, just identifying the M and the B, but that's basically where our equation came from. Part B says, use your equation to predict the amount of calories burned after 16 weeks. So if you remember, equation from part A was y equals 516.03x minus 194.28, okay, where x represented weeks, and we know that from the table, and y represented how many calories, and again we know that from the table. Now they want us to predict the amount of calories, so we don't know y after 16 weeks, so we do know weeks is 16. Now keep in mind we don't have to add or subtract here because before the example was how many weeks after, or how many years after 1995, but this is just weeks. So we're going to plug in the x value 16 into the equation. So we're going to get y equals 516.03. There's an x, so in parentheses we're going to plug in, we're going to substitute the x value for 16 minus 194.28. Okay. If you want to go back to your calculator, just go ahead and click the home button and then select calculate. And you should be able to type in all of this in one line to give you the answer of 8,062.2. Okay, so how many calories will we burn after 16 weeks? 8,062.2. Now let's put that in a short sentence. After 16 weeks, 8,062.2 calories will be burned. And that'll be our final answer for that question. Okay. Now, keep in mind, this is the end of the notes for target 8B. Any examples, any problems that we didn't get through done in the packet for 8B are your responsibility to complete for practice and for homework.